Hi Taj, good morning. Good morning, guys.
Hi Taj, good morning. Good morning, everyone.
Good morning, guys.
Morning, Taj.
Hari
Morning,
Prasad Rajan.
Taj.
Good morning, Taj.
Morning. Because I don't want to, because when I start the training, that on that time I want to start the recording. I think somebody has. Okay. So before I could start, guys, so let me take attendance. Hari, you are present. Okay. So let me mark first the attendance. Okay, Sahan is present, guys. Sahan, Santosh. Guys, is it I'm audible, guys?
Yeah,
Yes,
Taj.
Taj.
Yeah, just marking attendance, guys. Please just read out your names. Sahan, Santosh, Mohan Kumar, Anjan, I think he's present.
Yes.
Yes. Kiran,
Yes, I am present.
Vishwanath.
Good morning, Taj. Yes, I'm
Very
here.
good morning. Diksha. Chandan. Ammu, Maria, Jayan.
Hi, Taj.
Amisha.
Good morning.
Okay, very good morning. Amisha,
Taj.
Shashikant. Punit Kumar.
Present, Taj.
Okay. Hari Prasad Rao. Okay, he is present.
Yeah, Taj, I'm present.
Navya Raj.
Present, Taj.
Okay. Satish Kumar Annamalai. Trinidhi.
Present, sir.
Ratnakar.
Hi, Taj. Good morning. I'm here.
Morning. Satish Kumar. Veena. Lalit.
Present, Taj.
Yeah, I think Veena is she joined. Okay, I think Chandan has pinged me.
Hi, Taj.
Chandan, right?
Yes, Taj. Yes.
Yes.
Thank you.
Santosh, Mohan, are you there, guys? Santosh, Mohan, Sahan. I hope, guys. I think yesterday we had a lot of theory part, right? IP addressing concepts. Do you remember, guys, all of you? Yesterday's? Hari, you are sitting on the mountain and nice beach background.
Yeah, Taj.
Guys, today a lot of lab, guys. So I'm going to just spend 45 minutes on the theory part. Okay, then we'll take 10 minutes break. Then we'll do the lab. 2 hours, 2.5 hours, we'll do the lab today. Okay, so what are the things I'm going to discuss? Let me share you my screen. So here I have planned to take a spanning tree also we shall discuss today, we'll see. So actually I have planned to start with your VLANs. Yesterday I think we have done some VLAN concept, right? How to create the VLAN, how to assign your ports to the VLAN, how to create and verification of the VLAN also we have done. And today we are going to discuss about your trunking. Okay, and before that, guys, I want to explain like about the switching, how the switch works. Okay, some of the slides I have. Okay, I think I have shared your my CCNA slides, guys. If you want, I will share you that one slides. Okay, so then we will jump to your dynamic trunking, that is DTP. So dynamic trunking protocol. So anyone familiar with these topics, guys? So then we'll go for your inter-VLAN routing. So using separate physical gateway. There are many methods. Okay, I will do all the methods, guys. Using separate physical gateway and inter-VLAN routing using sub-interface. Anybody familiar with these topics, guys? And one more is using your multi-layer switches also will do. So topics are very huge, guys. So it takes long time. We'll see how much we can able to do it. So regarding the switch, guys, I have the slides. I think CCNA day 4, you can see on the slides which I shared to you. So there we can see, I think some of the topic I explained how does switch works, how does switch will forward these things. Okay, how does it generate prepare the MAC table by your switch, guys. So you want me to explain once again, or can I jump to some other topics like? So let me start with some features of and some basic concept of the switch. So right now, guys, we are discussing only your layer 2 switching concept. Okay, so layer 2 switches, then we'll go for layer 3 later. Okay, so as we can see, you can see my slides. Okay, can I start, guys?
Yeah.
Yes,
Yes, Taj.
Taj.
Yes, Taj, you can
Yeah,
start.
Taj.
No, only one guy has turned the camera, I think. Only Hari has on the camera. Others they didn't on. Chandan, Ranjan, Vishwanath, Srinidhi, Kiran, Diksha, Ratnakar is on. Oh, Srinidhi is sitting in some space, I think, in NASA lab. So Amisha has on her the camera. Diksha, so on. So let's see, guys. Today I have planned a lot of topics, lot of labs, guys. Yesterday, I think we have spent a lot of time on IP addressing, right? So do you remember, right, IP addressing?
Yeah, we do.
Diksha, you understood? Naviraj, Amisha. Is it I'm audible? Amisha and Diksha?
Yes, Taj. Yes, Taj.
Diksha, if my CIDR value is /24, what could be my subnet mask?
Uh, 255.255. I need to calculate.
There's no need to calculate. There's a default, it's there.
Yes.
Amisha, can you tell?
Yes, Taj, it is 255.255.255.0.
Okay. Now, if it is my CADR value is /27, what could be my subnet mask?
Two 255.255.255. 1 second. 240.
I guess because this is quite very important in coming the labs. Okay, so that's the reason I'm asking that to get alert always, because it's easy, guys, because once and twice if you do some practice mathematics, we can remember for a long time. And don't try to mug up this subnet mask. Okay, don't mug up. We cannot mug up all those things. Okay, so let me start, guys. So as we know that, so let me share my screen. Your latest switches, guys, break up the large collision domain into your smaller ones. Okay, so collision domains of the network segments will have the 2 or more devices share the same bandwidth. Okay, so as you know that switch will be connected, so to share your same bandwidth. So hub network is basically this example, this type of technology. So most of the previously they were using the hub, okay, to connect to the devices. So nowadays almost all every organizations they are migrated to the switch. So it's nobody using the hub, but it's talking about is similar, look like your hub. So each port on the switch is actually its own collision domain. So each port on your switch, it's a collision domain by itself. Whenever you connect your PC, so you make a much better Ethernet LAN network just by replacing your hub to switch. So it's recommended, as I said. So they have shifted to hub to switch. The reason is, as you know, so whenever you want to communicate on your hub, it broadcasts every time, which consumes the more bandwidth. If the bandwidth increase means obviously your network performance will come down. Correct? So we'll come to the switching services. So unlike bridge, use the software to create the manage your filter table using the application specific integrated circuit. Okay, so layer to switch and bridge are faster than your routers. Okay, just remember, guys, this is the all technical questions. Your bridge and your switch is the faster device than your router. Okay. So they do not, even if you check, if you got any chance to see this router and switches, the real physical devices. For switch, there's a no on and off button. For the router, it has switch and bridge. Whenever you connect your power card to the power supply, so directly it on. There is no power on and off button for the switch, switch and bridge. Okay, so they don't take they don't take uptime looking at the networks layer header informations. So literally it will come up because see it is totally it's talking about the frames. Right now we are dealing with a layer 2 switch, guys. So they look at the frame hardware addresses before deciding whether the frame what. So what is talking about, guys? They always see about your frame hardware addresses. So before deciding whether to forward the frame or drop, you have to remember that because first if it's as I told, it doesn't bother about your IP header or IP address. Okay, so first you will see the frames and decide whether you want to forward or it want to drop. And layer 2 switches is very efficient. You can connect your all end user devices. Like what are devices you can able to connect? So later I'm talking about your layer 2 switch, guys. So we can able to connect, guys, your end user devices. You can connect your servers, whatever servers available in your organization, like your web server and your DHCP server and your proxy server and your wireless controller and even you can connect your web server also we can connect. Even you can connect your this one ICE also we can connect. ICE device also we can connect, where it will check the authentication of your users. So identity search engine, guys. This is a Cisco product. Okay, there are the few features of for the layer 2 device. These are the devices we can connect. Okay, so I'm talking about a layer 2 switches. Okay, so now how switch and bridge learns. So the switch also learns the same way as how the bridge learns. Read the source MAC address of the each receiving frames or a datagram. So it receives the datagram. Okay, datagram or frame. Record the port on which the MAC address has been received. So I think yesterday I told you that. So whenever any PC is connected, you want to communicate with other PC. Okay, so every PC has got the MAC address, right? This is a AAA and BB. Okay, so when the PC sends the message, okay, that is your ARP message, it's read this MAC address. It'll build your MAC table. It will build your MAC table, which contain your MAC address and interface name. So in this way, the bridge and switch learn your addresses before belongs to the device connected to the each port. So they will learn it. So example, guys, I think, so I can, so you are in your batch. So I am familiar with a few names now, right? In this group. So after, I think another 2-3 days, so I can remember your all names, right? So I'm taking time to learn my MAC address, I would say. Understood, guys? Because I'm reading, because I'm reading to whom you are reporting, who is your manager, and what is your name, what is your job role. You're supporting L1 and service desk. So I can see, so I can record it. So I think Chandan is doing that. Okay, Hari is doing this job. So Hari is reporting to so some Purna Rao and Shilpi, and even so like Anjan has, I can remember the names, right? Same thing, it takes time, okay, to build up my MAC table on my brain. I hope it is understand, guys. So this is where how your switch is going to work. Okay, so Ethernet access with the switches, so it will create separate path to avoid the collision. So multi-device send the data at the same time. So each node has a 10 and 100 Mbps speed. So if you talk about nowadays, guys, so even nowadays you have 10, 100 and 1000 Mbps. And do you know, guys, in your company laptop, what you have received, do you know what is the speed of your port? What is the throughput of the port? These are the series, guys, 10, 100 and 1000. So your laptop and our laptop right now, the office laptop I'm talking about, not your personal laptop. So office laptop, the capacity is 1 gig, guys, 1000 Mbps. Where you can see, okay, how you can check, guys, this one? How we can check?
Speed test by doing internet
How?
like that.
How? If I how I can check? Lalit, right? I'm right.
Hi, Taj.
Just so how do I check? Like, of course, I'm getting reply. This is the IP address of your Google. So how do I check what is the capacity of my port? Same laptop, right? Same thing. What laptop you have received? Same thing. I have also got my same Dell laptop. So go to your interface, guys. Okay, this is the one where we have connected. So right click and go to status. So here it will see your speed. You can see, right, 1 gig. Understood, guys?
Yes, sir.
Now you check from
Yes.
your side, guys. I'm sure you people, I think wireless connected, right? Almost every guy. Now I have connected physically, guys, because as you know, it is an online training. The other reasons I have connected to my port. So the port throughput of the laptop is 1 gig, and the other port which you are connecting, that also should be the 1 gig, 1000 Mbps. Did you check, guys, all of you?
Yes, Taj.
How much you are getting? Same 1 gig. And those are connecting wireless, I think it's cannot see. If you connect with the cable, then you can able to see that. So my speed is 500 Mbps, and see, because it is connected to my Chennai server. The reason why it is coming down by this is a little peak time, because it's a working time. The traffic will be very huge. Understood, guys? This is how we can check the speed of your ports. So Ethernet switching. So you know the basic function of your Ethernet switch is address learning, forwarding, filtering decisions, and loop avoidance. So this is the main concept how your switch is going to work. The basic features of the switch. Okay, there are 3 features which works your switch. Okay, that is unknown unicast addressing, broadcasting, and multicasting. So these are 3 conditions which will flood a frame out to all the port except the port on which the frame has been come. Okay, except the port which has been received. It will send your broadcasting, unicasting, and multicasting. Okay, it's quite very important because whenever if I ask any question, because now I can remember some of the names in your batch. So sometime I will ask the specific questions, like specific questions with Diksha, or Ramisha, or Lalit, Chandan, okay, or Ratnakar, because I know now I remember few of the names. Okay, because when the first day and second day, so what I'm doing, I'm just sending the question to all. What is that? That is broadcasting.
Yes, right.
Yes, that is broadcasting, because I don't know your name. Because I don't know your name, so first day 1, day 2, so I keep on sending the questions. Anybody can know the answer, they can answer it. So this is what I'm asking. Same thing here concept. Okay. So how your switch will learn the MAC address? You can see, just remember this MAC address for the PC A and C, B, and D, guys. So we have to remember, guys, because most of the network engineer job will be on the switching, not on the routing. Remember this, guys. So this is your initial MAC address table is empty right now. So you can see the table is empty. The table is your empty. Remember, most of the job for network engineers will be having job on the switching concept, not on the routing, because routing one time we can going to configure. Okay, right? When you configure any routing protocol, just once the communication has been completed, so there is no job there in routing part. But you should know about the routing, which is also very important. So switching will be having the more job. Okay, so just pay some attention, guys. So how switch will learn the MAC address? So what it does, we can see, guys, here station A send a frame to the station C. Station A, this guy has sent a frame to station C. What it does through this interface. Okay, so what happened? Switch calls the MAC address of the station A for the port number E0. Okay, by learning the source address of the data frame. So the frame from the station A, station C flooded all the ports except the port itself. So what it does means, so this will make an entry. Okay, what this MAC address will make the entry. What is this? This is your interface name, right? This is the name of your interface. Okay, this is the name of your interface, and this is your, as you know, this is your MAC address. Okay, so now what happens next time? So station D send the frame to your station C. Now this guy has sent. So this guy has sent to the station C. So what happened? So this guy will make an entry with the interface E0 because it has learned from your E0, and this is your MAC address. It will make an entry. Okay. So now again, station A send the frame to the station C. You know, right? So again, these guys send the frames to station C. What happened? Now this time it will not broadcast to all. If you see the previous slides, okay, so you can see. So when station A send the frame to station C, so it broadcasts to all guys. You can see the arrow mark, right? Right. When the station D sends, it broadcasts to all. It broadcasts to all, even this guy also it will broadcast. We can see it will broadcast to all these guys. Now next time, if station A said again, if station A want to communicate with station C, it doesn't do the broadcast now. Before broadcasting, it will check its MAC table. So whether this MAC address, station C MAC address, it is available in my MAC table. Yes, it's available. So directly it will send. The switch, what it does means your switch. So it doesn't do the broadcast, it's sent directly. Means we can reduce the bandwidth of your switch. So unnecessary broadcast a storm. So we can avoid it. Understood, guys?
Yes, Taj.
Destination unknown, frame will not be flooded. Your frame will not be flooded. The broadcast and multicasting frames. So station D send the broadcasting or multicasting frame. So as on that, it will broadcast to all. This guy and this guy also it will broadcast. Okay, it broadcasts to all the ports other than your originating port, other than by himself. Himself, it will not forward your frames. So one of the best job by switch we can do it. So when the frame arrays to the switch interface, so destination hard is compared for filtering and your MAC address database. So it maintain your MAC address database. If destination address is unknown and the list in the database, the frame send out only to the correct exit interface. It will send to the exact exit interface to whom you want to send before sending. So next part, what is talking about? So if doesn't available in the MAC address in these things, then what it does means what will do? It will broadcast to all. If the MAC table is not available in this table, so what is going to do? It's going to your broadcast to all the active ports except the ports himself or except the port which is originating the frames. So this is one more example he has given. So learning how does it will learn MAC addressing table. So this is the MAC address. This is the PC3. This is the switch 1. This is my switch 2. Okay. How does it work? When this frame has been sent. Okay. So when this frame has been sent, so what it does means first we will make an entry with the interface name. Fast Ethernet 0/3 because this is the interface. Okay. So then what it does? It sends to down. Okay. So now it will make an entry with this interface, same MAC address. You can see the MAC address are same. It has this MAC address has learned from your Fast Ethernet 0/24. So now if you connect one more PC, okay, so we can see this is the MAC address. It has been learned from your Fast Ethernet 0/11. It will make an entry. Okay, again, it will forward down. Again, this guy also make an entry because it has learned the different port, right? It will not learn with the same port because this piece is connected to the your port number 11. Okay, because for this switch, so this MAC address he has learned from this /24. Okay, now if you connect PC here, and this is your MAC address, okay, which is connected to your port number 12. Okay, fast Ethernet interface number 12, you can say. And it will make an entry in this table first, then it will forward to your switch 2. Okay, in the switch 2, it will make an entry because it has learned from your fast Ethernet 0/23, you can say. Okay, next time if this guy is sent, so destination, so I want to communicate with 0.1.1.1 MAC address. So what it does means before sending broadcast, first it will check its MAC table. The MAC table, this guy is available. Yes, this guy is available. So directly it will send. I think yesterday I told you same thing with our other guy. This time he want to communicate with this guy. So PC3 to PC2. So now it will check. First it will check his MAC table. If this address is not available, see we can see, okay, fine, this guy is available with the port number 23. Because port number 23, what it does, it forward your frames again down, your down switches. In down switches, okay, fine. So I have this MAC entry. So directly it will forward the frames, which is available on your port number 12. Your fast Ethernet interface number 12. Okay, so what is the loop avoidance? So as you know, that redundant links between the switches are very good idea because it helps to prevent your loop-free network. Okay, however, they often more problem because frame can be flooded down all the redundant links simultaneously. Right, because if you connect two links, okay, there might be chances. So example, if you see, so when the manufacturer FRET controller, okay, or this one, if you send any data, what it does, it will send both the sides, right? This side and this side. What this guy will do, again, it will send to this guy. Okay, this will receive. Okay, he also received the 2 frames here. Again, it will send to this guy. Okay, so because it has received from the 2 side, so it will receive. This will receive and forward to this data center server, and again, this guy also will receive it. So what happened? So this frame again it will come back. Again, it will receive with the new sequence number. Again, what it does, again, it will forward to this guy. So this guy, what had received from this side, okay, again, it will forward to this guy. Means this will become the loop, guys. Right? If the loop became very high, means what happened? Obviously, I think your bandwidth will come, network performance will go down. Okay, this is how we can avoid the loop avoidance. For the loop avoidance, the solution is your spanning tree protocol that we shall discuss in coming sessions. Okay, so the same thing is talking about, guys. If you discuss what I told just now, if you talk about, so when broadcast first received by switch 1 on the port 21, so /2/1, okay, same thing, it will forward to this guy, and again it will forward to this guy. Okay, means he will send 2 times here from this frame and this frame. Okay, when this received means he'll think that I have got the new frames, so again I need to forward to this guy. This guy think that I have got a new one, again it will forward to this guy. Right. Multiple frame copies. So as he's talking about, same thing what I discussed. So multiple frame copies are unique as whatever you get. So they are keep on exchanging the data to each other, guys. Okay, so which will multiple frame copies will be exist. Okay, the solution for this one is, guys, your spanning tree protocol. So let me talk about what is spanning tree protocol, guys, before going to this theory part. So redundant link in the network is extremely very important because redundancy links allows the network for your fault tolerance. Do you know, guys, what is redundancy? Redundancy, guys, any idea? Diksha, Chandan, Lalit?
Duplicate
Redundant-
copy.
Backup, duplicate.
Yeah,
Backup.
Redundancy link, yes. Because first remember, guys, spanning tree is very important in entire switching concept. Spanning tree protocol is very important. I want to add the two things. Two things you have to remember in spanning tree. The basic characteristic of spanning tree is, okay, whenever you connect the two link, one link by default is going to block it. Remember this. Because to avoid the looping, by default is going to block the any one of the port. Okay, that real lab will do today itself. Okay, after the break, so we'll do the lab. Okay, we'll do spanning tree, interVLAN, okay, and router on separate interface, physical interface, sub interface. We'll do a lot of lab, guys. Okay, so in another, I think 15-20 minutes. So I will be completing basic concept of the spanning tree. Then we'll jump for the lab. Okay. Okay. So remember, guys, so basic characteristic of the spanning tree protocol is going to block any one of the links to avoid the loop avoidance. Okay. So redundancy links based on the switch and bridge to avoid the multiple storm, multiple frames transmission of the MAC address table. Therefore, redundancy link require carefully planning and monitoring to function properly. Okay. So because sometimes most of the times because spanning tree take the major role for any network so that it will give the redundancy for your administrator so that your traffic is keep on moving. So when the one links go down, so it will route your to your other link. Same thing. Suppose if you talk about any ISP for any of our entity organizations, so they'll be having the three links, three lease lines. Okay, so because your traffic will never go down, guys, because they will be having the SLA for all ISP. Even single minute also that your package will never go down. Sorry, guys. Even the single minutes, okay, not single 1 seconds also it will never go down. Okay, now the spanning tree protocol are used to switch the network to create a loop-free network. Okay, spanning tree they come into picture. Okay, so if we exchange, I think you might know, but because there's a lot of videos on YouTube, because when you pass any information out of 100 people, okay, you ask him to pass this information to the second guy, and second guy, third guy. If you talk about the last 100 guy, so my message will change. Do you agree, guys?
Yes, Taj.
Yes, Taj.
Right. Because even some people they don't know how to copy also. Right. So here duplicate is happening here. Okay, to avoid that, so they have come up with a solution that is your spanning tree protocol. Okay, to avoid your loop-free network. Okay, as you know that, so prevent the loop-free redundancy network topology by placing certain ports in the block states. Whenever you connect, it's one of the port. Any one of the port is going to block it. The spanning tree protocol resides in your data link layer. Guys, please remember this. Your spanning tree is going to work in your layer 2, guys. Remember. Okay, in data link layer. So Ethernet switch and bridge can implement in IEEE 802.1d. Okay, so IEEE, guys. So I was the member for IEEE for 2-3 years. I think in 2014, 15, and 16. There's a lot of meetings they'll call because no time to attend those meetings. I was a member for IEEE. Okay, so now how is going to use this IEEE standard 802.1d spanning tree protocol and use the spanning tree algorithm to construct a loop-free network. Okay, as you know that it has the inbuilt algorithm, okay, which will calculate to avoid the duplicate. whenever the frame comes to me, so make sure that first I will check whether this new frame is exist in my MAC table. So if it doesn't exist means what I'm going to do, I'm going to forward it. So algorithm will check for your duplicate. Same thing. I think you have the Facebook algorithm, lot of different kinds of algorithm, right? Right. So I think you notice, guys, if you check any YouTube video, so any songs or any news, okay, if you frequently you're watching the news means always news relevant videos will come, right? Have you noticed that?
Yes, Taj.
Yeah, we have noticed.
Yes.
Yes,
That is the
Taj.
job of, that is the, if you watch any music, suppose if you're watching the music for any, yeah, Salman Khan or Shah Rukh Khan, any musics, okay, you can see only those videos will come because that is the
Yes,
job
yes.
of the algorithm. So that is the job of the algorithm, guys. So here algorithm, what it does means if any frame is coming, repeating again and again, so it's going to block by default. That is a job because algorithm play a major role in all IT field, guys. I'm not talking about networking. So in all fields. Okay, so now what is STP, guys? Spanning tree protocol has got some port states. Okay, they have some port states. So blocking. Okay, so when loss of the BPDU detects. So let me discuss what is BPDU. Anyone know, guys?
Protocol
BPDU?
data unit. I think.
Bridge protocol data unit.
Yes,
Data.
yes, sir. Very good. Bridge.
Protocol data unit.
Very good. Bridge protocol data unit. Who is this? Is it Chandan?
I was knowing only PDU. Taj.
Okay.
I forgot that
Okay, guys.
bridge part.
Yeah, it's the BPDU, guys. Bridge protocol data unit. So before I'll explain about these four parameters. So let me explain what is BPDU, guys. Okay. Let me take my, because it's very important, guys. Let me draw this my switch. This is my downline switch. Okay, when you connect to this is, we'll call it the trunk link, guys. Okay, these are the two ports which we connected. So what does the BPDU does means every 2 seconds it send a message between the switches. Not 2 minutes, every 2 seconds. So in every 2 seconds, it's exchange the information between the switches. Between the switches, keep on exchanging this to this. As you know that when you connect two links, one link will be down, right? This is job of your spanning tree. STP, spanning tree protocol. Okay, so it will forward these frames. Okay. Now BPDU, what is content? So it contains your frame ID, user ID, so not user ID, your port numbers. Okay, that we should discuss more details about the BPDU. First, remember when you connect the two links, one links by default it got blocked. We can do in packet tracer. Okay, so by default it's going to block it to avoid the loop avoidance. Okay, BPD is one is keep on exchanging the informations. It's like me, guys, because I keep on explaining for the 3 hours. Okay, so sometime if you don't sing to me, say they should sing to me. Yes, that we are following. We understood that if you don't sing to me, what I will do is that's the reason I'm sending the BPDU message in every 5-6 minutes. Guys, you are following, you understood, right? That is a BPDU. Understood, because it will also check your keep alive message, whether the switch is up or down. Okay, this is my switch 1. Okay, and this is my switch 2. Okay, if this switch is down, this switch is down. So what it does mean when you send a BPDU message, if you not get reply, I think in 30 or I think 60 seconds, what it does means it stops sending the BPDU. It will make an entry that this switch is down. Right. keep alive, guys, because in the schools also you can notice in your schools. So I think you might having your friends. One of the friends will be he'll sleep in the school, right? Right. We'll send. We'll push him because teacher has make an entry. Please wake up. Because that is a keep alive message. That is the job of your BPD guys. Understood, guys?
Yes, Taj, yes.
Yes, yes, Taj.
Yes, Taj.
So what is it, guys? So BPD message, what it does means that's the reason it's talking about. So what they are, there are some port states for the spanning tree. There are several different states blocking. Loss of the BPDU detected, right? So when the two switches, okay, if the BPDU message not received, if the BPD message not received, as you know, this is the block state. Okay, you're not getting reply from this side. Okay, what it indicate that the BPDU has been lost. So this take 20 seconds. Okay, if you not reply, is this switch your switch one. Okay, it will wait for your 20 seconds. Okay, then you try to listen it. So listening, it takes another 15 seconds. Maybe after a few seconds it will come up. Okay, so forwarding, okay, it takes your 15 seconds. So he's talking about when these links, as you know, by default is going to block, this link will be active. So what happened when this link is down because you're not getting reply from your BPD message. So then he has to activate this link. Automatically it will on. When you this link are down, this link are not getting a reply BPD message that indicate. So this has gone down. I need to make up this one to come up this one. These are the parameter it will come. BPDU has been detected. So we have lost the BPDU. So it wastes 20 seconds. Okay, and listening. It will listen for this these ports with these links. I have to make this active. I have to make it up. Okay, for listening, for learning, it takes another 50 seconds. To learning for entire this one, it take 50 seconds. Then it will forward your frames. Then it will come up. Means totally how many seconds it will take? So 20, 15, 15. So how much will come?
50 seconds.
Almost. So 50 seconds. Okay. In the 50 seconds in the production network. In a production network. So is not acceptable. So this is not at all acceptable, guys. 50 seconds is almost 1 minute, right? 1 minute, there's no internet, guys. No internet, no connectivity, almost. Correct? Guys, good morning. Are you there, all of you?
Yes, Taj.
Yes,
Yeah.
Taj.
Yeah, that's
Yes, Taj.
Yes, yes, Taj.
Yes, Taj.
I'm sending the BPDU message, guys. Otherwise, I'm going to block you all.
So, Taj, I have one question here. So, if both
Yeah.
the links got blocked, then what happened in that case? If we are sending messages and
Yeah. The question here, what I think, who asked? Amisha?
no,
Diksha.
Diksha.
Diksha. See, so when the two links go down, usually the two links will not go down. If the two links go down means that indicate that your neighbor switch is completely down. It doesn't forward the any frames.
Okay.
Because first of
So
all, if you don't have the connectivity, yeah, Diksha.
So it will never happen. Like both the switch never got down at the same time. And one will
Yes.
be always active.
Yeah, one will be active. Both will be active.
Okay.
Both will be active because the spanning tree job is why you are connecting two links. The reason why you are connecting to avoid the loop avoidance. Okay. And second thing is to get the redundancy link. One links go down, it will route with the other link.
Okay.
Okay. When one links go down, when one of the links go down, so how it will come up the other link? These are the parameters. Okay. So listening, learning, and forwarding. It takes almost 50 seconds. It's almost 1 minute, right? is almost 1 minute in the production network, which is not acceptable. Right. So for coming up the link, it takes a lot of time, right? Because even 1 second, 2 seconds in the any network is very important. Just imagine. So one of your customer is banking. What happened? 1 minute network down. 1 minute, I think, say example, if you make the transaction about 100 crores, do you know the commission for that banking? Suppose if I transferred 1 lakh rupees to your account, banking people, they charge, right? Some 4 rupees, 50 paisa. Do you know that, guys?
Yeah.
All of you?
Yes. Yes, Taj.
Okay, suppose if I send 1 lakh rupees to your account, within the 1 minute, there will be like lot of like thousands of bank account holders. They make the transaction, right? In 1 minute. If you consider minimum like 100 crores, so what is the commission for the bank? 0.4% if you consider also, so they'll be lost to I think 4 to 5 lakhs rupees only in 1 minute. Right, because the client, the customer, okay, they will be having the SLA, right? Because when this network go down means the company have to pay. I think Hema, I think she worked in Goldman Sachs. I think that is the best example I can say for Goldman Sachs. They paid some billions of dollars to New York Stock Exchange. That is, network downtime is very, very critical in any organization, especially the organization like banking, defense, healthcare, and your production network and ISP sites. Very, very critical. The good engineer, good network engineer is one who will utilize the proper utilization of the device, proper utilizations of your bandwidth. Okay, bandwidth is not a free of cost, right? You have to pay the money for the ISP to the people, right? Bandwidth is not a free of cost. The proper utilization of the bandwidth, the unnecessary frame, unnecessary packets. So we should block it. Okay. So let me jump for this one now. So what happens is it cannot be happen. So two links will come down. So these are the few parameters. So for this solution, guys, so again they have come up with your per VLAN spanning tree protocol, PVST. So again they have come up with again RSTP, rapid spanning tree protocol. Okay, and MSTP, multiple spanning tree protocol. So these are the things we are going to discuss, guys. We will discuss PVST and your MST also we shall discuss. Okay, now after this we'll go for the break now. So what is the time now? Okay. So selection of the bridge and non-bridge port, guys. First, remember when the first decision taken on the networks, it identify the root bridge. Okay, we'll be having a lot of switch in your organization in the rack. Okay, so there should be one the root bridge, like a team leader, like team lead. Okay, when the switch is turned on, spanning tree algorithm is used to identify the root bridge. The BPDU send out all the bridge ID. BID means your bridge ID. So bridge ID, what it contains, consists of your bridge priority. The default priority is your 32,768, and based on your MAC address, who will become the root like team leader. So if you connect 5-6 switches, when you on all the switches at the same time, all the switches, your bridge ID will be same, right? If all the bridge ID are same, so then it will take the MAC address. When the first switch is up, is assume that so it is the root switch and send the BPDU. The BPDU contains your bridge ID. The bridge ID is this, guys. Remember this number, guys. 32,768. This is your default priority. Bridge priority for all the Cisco switches. All bridge see that decide that bridge and the smaller ID bridge ID will be became a root bridge. Okay, here smaller one will be. We can make changes, guys. Spanning tree. If you give the root primary, we can give the values by changing the values like 4096. If you make it, so that guy will become your root bridge. You can make team leader whichever you want on your switches. But here, so before that, when you connect all 2-3 switches at the same time, so they'll fight each other. So I want to become the root bridge. But they have the same root because Cisco device, right? So all our bridge priority is same. So in that scenario, that what happens means they'll go for your lowest MAC address. Who has got the lowest MAC address? You know, for every device, they'll be having a MAC address. The lowest MAC address, that guy will become your root bridge. Or if you are automatically, it will select out of this one, spanning tree will work. This algorithm, spanning tree algorithm, that will check who is has got the lowest MAC address. That guy will become your root bridge. Or it has got also manually, if you don't want to make the switch 3 out of 3 switches, you want to make switch 1 as the root bridge, manually we can reduce this value by 4096 or any value, we can reduce the value. That guy will become your root bridge. Your network administrator may want to influence decide by setting your switch priority by smaller value by default. We can change as I just said. So if you want to, we can reduce the value. That guy will become your root bridge. So you know, bridge protocol data unit. Okay, it's exchange. This exchange information to use in the selection of your root bridge. You know, BPDU is quite very important because keep on exchanging. So in BPDU message, it contains your bridge ID and your priority bit. The priority bit is 32,768 for all Cisco devices. Okay, how spanning keep track for all the switches in the networks? So determined by your combination of your bridge ID. So what is the root bridge? So lowest bridge ID became your root bridge in the network. Why? Because guys, you know what happens in your team. All the team leader means what happened, man. Nobody is going to listen each other, right? I'm correct, guess I'm wrong.
Yo,
Yes,
correct,
Taj.
Taj.
Correct.
What happens if all people are team leaders? Nobody is going to listen. Who are you to tell me? I am also a team leader, right? Okay. Okay, now what happened, guys? Root bridge. So what is talking about? The root bridge, the lowest bridge priority became your root bridge. Root bridge is nothing but your team lead, guys. So non-root bridge. So these all the bridge that are not belong to the root bridge means lowest priority value. So example like this is 73068. So again, if you reduce to 4000 means it will become so 82,768 because this guy will become your root bridge and this guy 32 will become your non-root bridge. Okay, because lowest guy will become your root bridge right here. Now what is a root port? Root port is always the link directly connected to the root bridge or smaller part or shortest part to the root bridge. If more than one link contained to the root bridge, okay, then the port cost is determined. Suppose if you connect 5-6 links to connect it. Okay, if more links are connected to the root bridge, then the port cost is determined to check the bandwidth of the each link. So what is talking about, guys, here? So let me write it down here. So these are the 2 switches, so which I connected. So as you know that one link is going to block it. Okay, so how it will select the root port? The port which has got rights to forward your VLAN traffic or BPDU, not all the traffic, all the links. Okay, when these links, if all the priority are same, okay, even your priority are same and your this thing your BPDU message are same, what you do me, it will go for the cost. lowest cost is the best. Remember guys here. Then, so this port will become this thing. Say example, so you connect another two links. Let me draw the diagram here. So when you connect one or two links in your switch, so as you know, so one of the links is going to block it, right? So when the priority is what? 32,768 and same priority for this switch also, right? So if the priority is same, okay, you can reduce this value, right? You want to make this guy as a your root bridge. Okay, and this is your non-root bridge. Okay, how we are going to do? Just we are reducing the value, okay, by 96. Then lowest is the best, and this guy will become your root bridge. Now, if the priority is same, if you are not meeting this one, then you will check the link speed. You'll see the cost. Link speed is nothing but your cost. Remember, lowest cost is the best. Say example, I'll write some of the cost and link speed. Okay, if the link speed is 100 Mbps, I think cost is 18. The link speed is 1000 Mbps. Cost is, I think, 14. And if it is 10 gig, the cost is, I think, 8 or 4. Some are for 4 here. The link speed is 40 gig. The cost is 1 or 4. This optical fiber. This is all the optical fiber. Means lowest cost is the best. If you connect it with this one, as you know that, so this is the CAT cable. Some cable are connected with 100 Mbps. Some are connected with 1000 Mbps. So what we'll do? So if the lowest cost is a gig, if it is connected with 10 gig, okay, and this guy is the best path. This is the best one. What you do, and this guy will become your root port. Correct, guys? Understood? Guys, understood or not?
Understood.
Yeah, understood.
Yes.
You know about the cost, guys? Anybody in your team? What is cost?
Yes.
I said lowest cost is the best in the link speed. So here I said, I talk about the root port. What about designated port is the one that have determined to have the best lowest cost. The designated port will mark as a forwarding port. Designated port. So only one port can forward any updates. In your switch, the new VLAN if you create, okay, you need, okay, that switch has to give the update to the neighbor switch, right? So what it does means only the designated port has rights to update to your other switches. Not all the switches which is connected, so they cannot give any updates. Only your designated ports. So non-designated port, the switch one, which has got the higher cost. Non-designated higher cost. Maybe I think link speed is very slow, and those ports will become your non-designated ports. Forwarding port, which will forward your frames, okay, for your VLANs, for your end user devices. So blocking port is the part of not forwarding in order to prevent your loops. So by default is going to block by spanning tree, only one of the links to avoid your loop avoidance. You understood guys about a spanning tree? What is a root bridge? What is non-root bridge? Root ID. What is the root ID? Designated port, not designated port. So this diagram shows you that how your root bridge selection process. According to this diagram, guys, so who is the root bridge here? This is my switch X and this is my switch Y. So you can see this is my switch X and this is my switch X and Y. So as you know, switch. So as you know that, as I said, every 2 seconds your BPD message will be exchanged between the switches. Your bridge protocol data unit. So your root bridge with the lowest bridge ID. So in the bridge ID, it contains your bridge priority and MAC address. So what is the default bridge priority number, guys?
32768.
32768.
32768.
168.
Right. So MAC address means whichever the MAC address it contains. In this example, which switch has become the lowest bridge ID, guys?
Switch X,
X.
lowest MAC address it is having.
Okay, so this guy, right? So
Yeah.
this guy
Yes.
became your root bridge, right?
Yeah,
Bridge.
definitely.
Fine. So spanning tree operation. So just remember this parameter, guys. So one root bridge per network. There must be one in one network. They must have one root bridge. Okay, one root port per non-root bridge, guys. Okay, so one designated port per segment. They must have one designated port who can forward it in the segment. And non-designated port are unused. Means these are the ports which is blocked, so we are not using that. So this will be act as your redundancy link as well as the loop avoidance in the network, so that it will not repeat again and again. Okay, this is the cost, guys. So which I was discussing. The link speed is 100 gig, sorry 10 gig. Okay, the cost is the revised is 1. This is the old one. Cost is 1 for 1 gig 4 and for 100 Mbps 90. Okay, for 10 Mbps 100 means lowest is the best. Okay, if you talk about 40 gig now 40 gig also come. I think 1 even 100 gig also come. That is 1. I think this has been replaced to 4. This is 2 and this is 1. Means 100 gig. So these ports are exist in your Cisco Nexus switches. So each port capacity is very huge. That is 10 gig. You have to remember this, guys, cost. I'll give one scenario, guys. Okay, so one road piece. Let me talk about this one. I will give one scenario. Let's see how people will understand. Okay, so I'll draw one switch here. I think slide is there. No need to this thing. The switching concept. Next configuration has come now. We are almost near to this thing. Let me explain this. What is a cut through switches stored and forward? Okay, so I'll explain very simple way, guys. So cut through switches is one which forward the frames before entering the frame in the receiving side. The minimum frame distance must be reached for each frame before you forward, it will check the error detection. Whereas free modify and cut through, okay, is one which filter out the collision frame before forwarding begin. Okay, before forwarding, it will check whether it has got any collision. Okay, store and forward. Before forwarding, it will store and it will send it, so that it will maintain the backup for storing for the further use. If you talk about switching method concept here, so we can see the, I think, preamble 1-bit SFP designated hardware address, source hardware address means it's talking about your source MAC and destination MAC, and length, data, and FCS. FCS will be there for all the your headers. So now, if I write, so this is my cost is 100 Mbps, and this also 100, and this is 1000. This is 100. I'm writing the link speed, guys. So this is my switch 1, and this is switch 2. This is switch 3. And here is 10 gig and 100. So now you tell me, according to this my diagram, okay, so who is the root bridge? Who is the root bridge, guys, here?
I think
So as you know, the priority is same, right? The bridge priority is same for all the Cisco switches. I think 32,768, and this guy also got 32,768. Then who is the root bridge now?
Switch
I think
3.
10.
Switch
Switch
3.
Switch 3, Raj.
Switch 3.
Switch 3?
Switch.
Yes.
Yeah,
Yes, because
switch
of
2. Yeah, 10
the
GB.
cost, right? The link speed is
Cost.
high.
Speed is
Link
high.
speed. Now, what is this port name?
Root port. Root port.
Root.
Yes, very good,
Root
very
port.
good, guys. This is the root port. Because you know, whenever this guy is sending any frames to this guy or this guy, any update, say example, you connected one more department, new department has been come, you connect to a lot of switches again, because this switch must give the update to all, right? Okay, he
Yes.
cannot give the update to the switch one. He must give update to first to this root bridge. This guy will become the root bridge. See, as simple as this, guys, because you know, whenever they, I think those are team lead here. Anybody team lead here in your team, guys? Sitting in this bed? Anyone team lead?
Yes, Taj, I'm here. Vishwanath.
Oh, Vishwanath.
Yep.
Vishwanath team lead. Because you know, if you want to give any updates to your team members, okay, until unless you received from your respective manager, so we'll not give any update, right?
No, I won't.
Right. It's simple as same concept here. Means, okay, yeah, you don't have any right, because no, if you got any update from your managers, then you update to your switches. So here the concept are same. So here what happens here, when you add new network, you create a lot of VLANs inside again. Okay, if you want to give any update, okay, first you have to give update to only for the root bridge. So you're not supposed to give any updates to your switch. Correct.
Yes.
Only this switch can update to this switch one. Directly he cannot give. Okay, that is a job of your selection of your root bridge is quite very important. So this will be given. So who has got the capable, like very high end switches? Okay, and maybe this switch is connected with a lot of your servers inside your organization. Okay, understood, guys?
Yes.
Yes, Taj.
Spanning
Yes,
tree
Raj.
protocol. So what are the port states for spanning tree, guys?
Block, learning,
Blocking,
listening,
Blocking, listening,
listening,
learning,
forwarding and
learning.
disable.
forwarding.
And issue.
Yes, very good.
Blocking.
Disable.
I think Venkat Reddy, are you there?
Yes, yes. This is my first class. Just trying to understand
Oh, that's
from
what
the
I
beginning.
see. Okay, okay. I think you missed 3 classes.
Oh yeah, I just got to know about this class now, and they asked me to just continue with this session, and I'm just trying to know what exactly is going on.
Since 2
From
days, Venkat, since I think this is the day 4, right? Today's day 4, right?
yeah,
Okay, first day we had some introduction first part, and second day we had discussed about the basics of CCNA. So what are the technology we are going to learn? Okay, and about my experience, some HR team, they introduced all those things. And I think yesterday we have started the main core of the course. So yesterday we had discussed about the IP addressing, what is switching concept, okay, and what are the security we have discussed. Not much, okay. You're not too late. You're on time.
all right, okay. Yeah, along with me, Karthik from my team is also available in the same
Yeah.
class as me. Probably let me
Okay.
try getting the recording sessions of the previous classes and go through
Yeah,
that.
it's available, Venkat. I think we can see the previous class. So we had not discussed much. Now you're on time now. Now we are going very deeper now. Today we are going to explain a lot of lab part. And make sure
Okay.
that tell to your team members to install the Cisco Packet Tracer, which is available in Portal Gas company portal. So if you want, I will show you. I think you can see here. If you open the company portal, so here we can install your Cisco Packet Tracer is available. So we can install it. Log in with your personal Gmail. It allow you for the 3 months. You can able to download this Cisco Packet Tracer.
Okay. Yeah.
In the portal is available. Okay, guys. So we'll take 10 minutes break, guys. Then we'll come back and we'll start doing the lab part now. Okay. See, Venkat, it is there on your
Yep.
these things because already I
Okay.
installed it. So we can ask them to install your team members. Okay. Because how we are planning, guys, whatever I do the lab. Okay. Can you on your camera, Venkat, if you don't mind?
Oh yeah,
I
sure.
want to see you. Okay. You are in office.
Yeah, I just reached office today.
Okay, fine. So you are sitting in the dark room. Okay.
Maybe.
Okay, fine. So tell them your team members to install Cisco Packet Tracers. So where I'm going to start the lab. So whatever the lab I do, so I'll send the PKT file because this in Cisco Packet Tracer, the extension of the file is PKT. Okay.
Okay.
So once the lab has done, I will share you in the Teams in the group. Okay, that file you can open in your Packet Tracer.
Yeah, sure. Let me try that.
Okay, so today I will send you once I've done the lab. Okay, before that, make sure you install the Cisco Packet Tracer. So once you install, what are the lab I did? So I'll share you in the group so we can open in your laptop. Okay, guys. So we'll see you after the 10 minutes break.